Hello ABM hums and gas. Welcome to our video lesson number 1 for plate tectonics. We will be tackling the continental drift theory today. Please make sure that you have the following materials ready: your gadget and internet connection, our document Continental Drift Theory Study Guide, which has been shared to each student. Just kindly open the doc from our Google Classroom and follow the instructions on the document. And of course, our slide deck called Plate Tectonics from our Google site, Earth and Life Sciences. We'll be looking at the following standards from our SMO. You can also click on this and it will take you directly to our SMO. For Type 1, state the continental drift theory and enumerate and briefly describe the evidences that support the continental drift theory. And these two will help us answer Type 2. Explain how the continental drift theory and seafloor spreading hypotheses have led to the formation of the plate tectonics theory, and describe how the presence of convection currents in the mantle caused the movement of tectonic plates. All right, let's begin. First up is an interactive activity. Every time you see this gear icon, the title beside it can be clicked and it will take you to a different website for the activity. So when you reach the Global Plate Reconstruction website, you can click on the forward or backward button on the bottom right and observe how the continents have changed positions from past to present. And then while you're observing, you may answer questions 1 to 2 in your worksheet, the Continental Drift Theory Study Guide. So let's go now to the website. It should take you to this Global Plate Reconstructions. So the buttons are here on the bottom right, and the labels, how long ago it has been, is on the bottom left. On the globe, the blue part is the ocean, while the brown is the landmass. And around here in the South Pole, you can see that it's covered in white. That means it's ice. All right, so now I'm going to click on the forward button, and I'd just like you to observe what happens to the land masses as we move forward in time. This is now around 400 million years ago. 260 million years ago. Now we're going into the time of the dinosaurs. That's the Triassic, and then Jurassic, and then Cretaceous periods. And finally, we're down to the present. So I can go back, and you can do this yourself as well, and move forward again. So while you're doing that, type in your observations in your document or worksheet. Okay, so let's go back to the presentation. So let's see. You can now pause this video and type in your observations. Welcome back. So if your observations sound something like the plates or the continents seem to have drifted apart from each other, like so, from 600 million years ago up to the present time, then your answer is correct. And the person who proposed this theory that the continents drifted apart from each other is none other than Alfred Lothar Wegener. He is German, an explorer and a scientist, and he traveled all over the world collecting data to support his theory, now known as the continental drift theory. And this theory says that a single supercontinent called Pangaea broke apart, with the pieces drifting from each other into their current positions. And you can see that on the right diagram, we've got the model of Pangaea, with the continents seeming to be glued together in a single supercontinent or landmass. That was around 225 million years ago. Fast forward to 150 million years ago, and we see that Pangaea has been broken up to Laurasia in the north and Gondwana in the south. Forward 100 million years ago, And you can now see the continents breaking into their sort of present positions until we finally get to the current positions. Okay. So now let's have a look at what Alfred collected, okay, the data and the evidences to support his continental drift theory. The first evidence is called the fit of the continents. And in this evidence, he said that, hey, have a look at this observation. South American coastline seemed to fit the coastline of Africa. They seemed to fit like a jigsaw puzzle. And the only explanation that he could think of at that time was that these continents were once joined together. Otherwise, they wouldn't have that perfect fit. Okay, so that's the first evidence. The second is called matching mountain belts and rock types. He also proposed that, hey, there seem to be matching rocks, that's the crust, matching mountains, and matching fold belts on the mountains, okay, across different continents that are now separated thousands of miles apart. So if you look at this green area here, this is where we have matching rock. The rocks that were found in Africa, some of them were exactly the same as the rocks found in South America, and these two are now thousands of miles away from each other. So how is that the case? How can they possibly have the same type of rock and the same type of mountain and the same type of folds? The only explanation that Wegener could think of was that they must have been joined together millions and millions of years ago and just separated into their current positions. Okay, so that's evidence number 2. Evidence number 3 is the wide distribution of fossils. So let's look at these guys. I'm pointing at the dinosaur-like reptiles or creatures. Okay, there's also one here on the top. And this evidence says that their fossils were found in different continents. Now, here's the thing. These were terrestrial animals, meaning they could not swim. So the only explanation was that they walked. How could they have walked if the continents were separated from each other? The only explanation to that, well, they must have been connected to each other. And it's the same with plants. Obviously, plants cannot swim, yet they found seeds from the same species in different continents that are now separated thousands of miles apart. The only explanation, once again, is that these continents must have been connected together to allow those seeds to travel through land. Okay? And finally, the fourth evidence to his theory is what we call matching glacial deposits or paleoclimates. Paleo meaning ancient. Let's read this out. It's a bit long. So rocks formed 200 million years ago in India, Australia, South America, and South Africa all showed continental glaciation, meaning there was ice in these areas 200 million years ago. And that is represented in this diagram by the white patch that you can see on Antarctica, India, and parts of Australia, as well as parts of South America and Africa. Now, if there was glaciation in those areas, well, there must have been a global ice age 200 million years ago. Global ice age means the entire Pangea should have been should have been covered with ice. But in some parts of the world, they discovered that there were tropical swamps. That is, these areas were not affected by the ice or glaciation. So this means India, Australia, and South America and South Africa were the only places that experienced glaciation and thus must have been connected together. And when they drifted apart, as you can see in the top diagram, they brought their ice composition with them. So if we are going to look at their ice composition at around 200 million years ago, we would also see that they would have approximately the same types of chemicals found in those ice. So same type of chemical in South America, as in Africa, as in India, and Australia. And the only explanation to that would be these continents or these land masses must have been connected together millions of years ago. All right, so I hope that made sense. Those are the 4 evidences to continental drift. Now, the bad news is that the continental drift theory was rejected by the scientific community during Wegener's time and also today, because the theory could not explain how the continents drifted apart. It just says that it did. So how did the continents drift apart? Well, that would be the subject of our video lesson number 3 when we tackle seafloor spreading hypotheses. It wasn't discovered until 1945 and only by accident. Okay, so for now, we can once again click on this link and it should take you to our primary resource for continental drift or plate tectonics in general. So to review the concepts in this lesson, read the section on continental drift theory, pages 1 to 5 from the linked resource, and then answer the remaining questions in your worksheet, Continental Drift Theory Study Guide. And then once you're done, you can turn it in our Google Classroom on the specified due date or before the due date. All right, thank you very much for having us today. I will see you in the next video lesson when we talk about the layers of the Earth. Have a good day.